Good evening. In our last lesson, we saw how we configure RIP, and in today's lesson, I want us to review the configurations that we did because I think I removed RIP on my routers. So I have since added this ISP router so that we build on as in we cover more concepts. Namely, as in we saw how we do no auto summarization, we disable auto summarization. So I want us to see what passive interfaces is all about. I think I demonstrated how we propagate a default route into your routing domain, but that's what I want us to review here. So let's first reconfigure RIP, because on my routers you can see I was actually verifying that when I type show IP protocols there is nothing. So we said with RIP or routing protocols the configuration is pretty much the same, because for RIP we said is router RIP and hit enter. You need to do no auto summary, then you do version 2 because you don't want to run version 1 because if you go back to the classification of routing protocols, dynamic routing protocols, and I mean the only other option you have to populating the routing table is static routing. But the drawbacks of this one is that it is error prone because it's manual. You can imagine if you're configuring a big network like this one, when you start doing, you see, for say the Northwest router to know about this LAN 2 that have 2000 hosts, you have to say IP route that network with its subnet mask and then the next hop IP address. There's actually another way that I did not show you, but we will look at it where you use the exit interface. That way you don't even need to remember the IP address here, you just use the exit interface, say when you're on Northwest. So that repetitive way of configuring or a static route, generally we saw that it have issues. So for the routing protocols, you can classify them as IGPs and EGPs. So EGP, exterior gateway routing protocols, the only exterior gateway routing protocol we have is BGP. This is the one that I explained last time. So right now we are looking at distance vector routing protocols, where things like RIP, EIGRP, these are the two. And here RIP, because you have two versions, you have RIP version 1, we're talking of RIP version 2. Yeah, and you can see that first of all, the predecessors to these two routing protocols is where you had RIP version 1, and this one you had IGRP. The problem with these two routing protocols, which are now legacy, is what we have here. They were classful routing protocols, meaning they couldn't work with CIDR. This is where we said that we no longer use class A, B, C. We now use things like /17, /28, now that we know how to subnet and all that. So we're still looking at RIP, and I think I've digressed and lost myself with what I wanted to talk about. So anyway, here we just want to configure RIP. So you type version 2, then you need to look at the networks that are directly connected to this router, yeah, to my R1. so that you start advertising those networks. Because I said the work of a routing protocol is to turn your routers into gossip girls, so that they start telling the neighbors. You see, like now my R1 will tell R2, hey, I know about this network here, which I did not put a label like this. So let me log into the device. I type do show IP interface brief. So the LAN gig is actually, you can even copy that. So this network here, Control V, paste, but is 0/24, where my gig 00 interface is is that one here, that have.1. So when I configure, say, RIP, my router 1 will start telling the neighbors, hey, I know about 192.168.1.0. So router 2 will automatically learn about that. Router 2 will gossip about what it knows, because we said that when a router boots up and finds its interfaces that are up, yeah, so when you do show IP interface brief, every interface that is okay at the physical layer, okay at layer 2, okay at layer 3, those networks are, the router will know about them because it is directly connected to them. So all a routing protocol does is take those networks that it knows, or essentially take the routing table, do show IP routes, show IP routes. That's how we look at the routing table. Just forget about the L. The L are what we call, at times we call host routes. Those anyway, it's just for this device to know it's a fairly recent feature that they added in later iOSs. In older iOSs they didn't have, they only had C. So anyway, I was saying that this /30/30 and all those, yeah, the C, the connected, I think I've belabored on that. So this router will advertise those networks to the neighbors. And anyway, this is what we did last time. So I do 192.168.1.0, and I said with RIP you advertise them in their classful manner. Here we have advertised .1.0, and it will cater for all these /27/30s. Yeah, I said in an exam environment, if you type, say, the specific subnets, yeah, in fact, anyway, to demonstrate what I'm trying to get at, let's create a network. Yeah, you can use loopback interfaces. So here I've just typed interface loopback 1. If you assign it an IP address 172.16.1.1, 255.255.255.0, which you can see is a class B address, but we have assigned it, we have subnetted, as in I've said, nowadays we don't even consider these classes per se. All we care is the prefix length, yeah, which is determined by the subnet mask. So I hit enter. If I go back to my router RIP, and here I'm doing parallel jumps. You're not supposed to come out from a mode and then go. You see here I was under interface configuration mode. I typed router RIP, I went to router configuration mode. You're first supposed to do exits and all that, yeah, especially when you're new to the iOS. So anyway, so when I do that, if I want to advertise this network to the neighbors, I'll do network 172.16.0.0 as if it was not subnetted. Yeah, in fact, if you do it as if you have subnetted .1.0, So I'm saying if you do it like this in an exam environment, it will deduct marks, because when you type do show run and we go to where we have router rip, I think I have passed it because I was using the space bar instead of enter. So you can see we typed router rip version 2. You see I typed it as a subnetted whatever, but the iOS wrote it as if it's a class B address that has not been subnetted. Yeah, so I think I've belabored on that enough. So what I'll do is pause the video, go to all the other routers and configure RIP, which or for the sake of those who are not there in class, so you just go to the other routers, you type router rip, and you need to first check what you have in your routing table. But for the packet tracer, because we have the topology, we can see that when you're on router 1, all the directly connected interfaces are just 192.168.1, this network here and this one, which I'm saying with RIP, you just type them in their classful manner. So you say network 192.168.1.0, and actually I did not do version 2, and you need to do no auto summary. Yeah, because if you don't do no auto summary, this is what I was explaining, that if you have a network that have just so that to remind you guys, let's say if you have a network that had, say, a router there connected to some LAN, then another router. So let's say this was the HQ that have, say, some server here that so let's say this is branch 1, branch 2, and let's say here now you have your clients at the branches that are accessing that server. Now if say you have this one is 172.116.1.0, let's say subnet, and then here you have 172.16.3.0/24, and let's say that the one links, you have something like 192.168.1.0/30, 192.168.1.4/30. Those is the one links. So maybe this is where you have is .5, .6, maybe here is .1, .2, yeah, of this network. Yeah, I'm sure by now we know how to represent these networks like that. So let's say we have a server here, and let's say this is 10.x 10 something network. Now if you don't disable auto summary, RIP version 2, you see it's a second generation from the good old RIP of RIP version 1, yeah, the legacy. Yeah, so it will still behave like RIP version 1 if you don't do no auto summary, meaning that B1 will not include, it will auto summarize, yeah, it will not include it as a /24. So it will auto summarize it, or it will, B1 will gossip to the HQ that I know about 172.16.0.0/16. So my branch 2 will also advertise to the HQ that I know about 172.16.0.0/16. So from the HQ router perspective, it will think that B1 and B2, they are somehow connected, yeah, because they are both saying that or when you're on the HQ router and you type show IP route, it will show you this route that it is doing equal cost load balancing. So the problem now comes when, say, this client here is accessing the server. Yeah, see, that traffic will go all the way. Let's say it's a TCP three-way handshake. It will come to the server, and the router will be able to route it good. But when it is responding, it might send some packets here and some packets here, because this router might do equal cost load balancing. So you can imagine things like TCP three-way handshake will never complete, and we will have connectivity issues. I hope I've made sense on that, but that's what we looked at in class, and this is what I was saying, that you need to disable that auto summary. So we go to the final router, we do router RIP, we say version 2, if I can type version 2, and you can see that I'm used to now hitting the tab all the time. I said that even in the exam environment it works, though if they want to test whether you know those commands, they might though really they'll require you to type the whole command. Yeah, the tab will probably work, and the question mark, yeah. So now we do the network. We know that the network is 192.168.1.0. I was hesitating because I've said the best practice is where you look at do show IP route, you look at your routing table, so that all the C networks, you advertise them. Or you can type do show IP interface brief, so that you advertise the networks that are directly connected to those interfaces. And you can already see that we have our network, as in we already have some RIP, RIP LAN networks. We can even see the 172 that I created on router 1. And this is where I was saying that this first number here, you will see it change when you look at, because today we were to look at EIGRP, but probably we'll look at it in the next video. So I say this is the believability or trustworthiness of a route source. Yeah. So now the next number is what we call metric, or the cost. So my router 3, because I'm at router 3, knows about this network here, and it is one hop away. It is one router away. Yeah. So what we mean by that, I'm at router 3, it knows about 172. Actually that network is inside here, but this router will see it as if it's one hop away. It is one router away. So if you look at this network here, 192.168.1.0, this here, you can see it is one router away. Yeah. The metric of RIP is hop count. Yeah, where hops are routers, the number of routers to get there. So my router 3 can see that I'll just go through one router for me to get there. So anyway, that's what we covered in the previous lesson. So I have added this ISP here. So let's first do the configurations. I have already done the base configurations, where basically I have gone to the other routers, copy the running config, edit it to have what we have here. Now I go to global config mode, interface gig 00, which is this interface here. A good thing with Packet Tracer, you can hover your mouse, and so it's gig 00. You do IP add .41.89.162.89.162 can't even type that thing, so let me do the lazy way of going about it. Copy, right click, paste. But on the ISP side is .1. We do 255.255.255.0. As per our topology is a /24, but we now know that a point-to-point link, you wouldn't want to give it a whole /24. That is too wasteful. But for this lab, we can just work with that. We do no shutdown. No shutdown. The interface have changed. The physical layer is up, but we know that it can't be. We type do show IP interface brief. Like I left IP interface. It's up, down, because the wire is not receiving electricity, because we have not configured on this other side. And this other side is interface gig 01. So we go there, do interface gig 01 IP add, and just paste it. And on this side is 2, do 255.255.0. Enter, no shutdown. Now we expect it to have turned green because we have configured it on both sides. So we have seen that, or this whole time of trying to configure RIP and all that is to populate the routing table, because we have seen that a router will not forward packets, as in for a router to forward packets, it will consult its routing table. So now this is where I asked if a router doesn't have, or how do you populate the routing table of the router to have every network, every network over the internet. So in that case, now it would be like if I come back to my laptop here and I do ping 8.8.8.8. now if it was a Cisco router that I'm using here at home, and it seems I don't have internet, I wonder what's up. So anyway, the routing table of my router have to have that network for it to forward it to the remote side. So in fact, we can even simulate that. We come here and we say interface loopback 0, then we give it an IP add of 4.2.2.2. can do 255.255.255 dot. Because it's a loopback, we can do all 255s. IP add 8.8.8 255.255.255.255. With loopback IP addresses, you don't loopback interfaces, you don't need to no shut them down. And I've realized that I've actually overwritten to show IP interface brief. Yes, that's what exactly I did. I typed this first address. I did not exit from that interface, so I have overwritten the IP address. So anyway, just need to do interface LO1, then I can do the 422 do show IP interface brief. I now have those loopback interfaces. Now we know that, or what I'm trying to say is my router 1, and technically this is now what we call a stub router. A stub, as in stub, and this is or essentially a stub network is a network that have only one exit. Yeah, you can see that, you see this whole network here, well, it have branches and all that, it have only one exit. That's what you call a stub network. This edge router here is what you call a stub router. So, and it's the one that we need to configure is the one that we are configuring here. So let's so we have seen that now we cannot run a routing protocol that is you don't run an IGP, yeah, an interior gateway routing protocol with your ISP, yeah, because interior gateway routing protocols are run within the organization. You can't run a routing protocol between here, and this is where we do static routing. So as much as we are trying to run away from static routing, we can't completely do away with it, because actually our networks will have at least, as in is always a blend of dynamic and static routing. So, but the way we do the static route here, because we cannot do static routes for every possible IP address over the internet, that's where we configure a default route on the, that is on the stub router. So this is where I said you do IP route, yeah, instead of doing 8.8.8, then you get the Facebook IP address, you type it here. So you say any IP address, use all zeros, then you say that have any subnet mask, because we were doing IP route, remote network, remote subnet mask, then you do either the exit interface. This is the one that I was saying that I did not show you guys how to configure using that, but we can actually do that. You do gigabit 0/0, because as we were doing the IP address, yeah, so you are telling this router, if you get an IP address that's not found in your routing table, just send it to gig 00. But in the class, that's where we are putting this IP address, yeah? The IP address of the next hop router. When you type all zeros like that, and it gives us a warning that a default route without a gateway, if not point-to-point interface, may impact performance. The reason for that is, you see, when you talk about gig is not a point-to-point, is a LAN interface, yeah? LAN interfaces participates in ARPs, in ARP. So what this one is trying to tell us is, if you configure a default route on a network that have, let's say, if our edge router, and I don't know whether I'm now losing you, if our edge router, because of the way I'm jumping back and forth, if our edge router was connected to something like this, maybe it's an MPLS cloud, sometimes, so what that is essentially what you call a multi-access network, just like the way we have a LAN. So let's say that this router now is the one that is connected to our internal network in question, yeah? So this is our stub router, is the one that we are configuring a default route. So if this is gig 00, and let's say that this router is the one that actually connects us to the internet, yeah, just a capital I there. So when you type IP route 0000 what, then you put this as the exit interface without putting the IP address of this router. When this router is doing the ARP, it doesn't know who do I send the ARP to, yeah, because in its routing table it will show this as the exit interface. So that will impact performance because it will sort of be broadcasting that traffic instead of directing it to that one router. So that's what they say that but for a point-to-point link like what we have with serial interfaces here, yeah, so you see, if I'm to configure a static default route on this router, I can comfortably use this exit interface because serial links, they don't use MAC addresses and ARP and all that. So ARP is a LAN, is an 802 dot it's what, the 802.3 protocol or whatever. But we can actually use the exit interface. In fact, it is recommended to do this because when you type show IP route, that is for a point-to-point, it's recommended to use this because do we have a static route anywhere? But I think we can use this. You see, when my router gets a packet that is going to this network, which network is this? We are on router 1.96 is this one here. So when my router gets a packet that is going to there, maybe is my PC1 trying to ping this PC here, it will do what we call recursive lookup. What we mean by that is it will see how do I get to this network, yeah. In this case it won't do recursive lookup because we have an exit interface. Anyway, I think I'm losing you when I explain it like that, but we will do one that have a static route without an exit interface. You see what I mean by recursive lookup. It can also impact a bit on performance and all that. So anyway, back to what we were doing. This is how we configure a default route, but in our case we are putting an IP address there, yeah. So now we can be able to ping 8.8.8.8. If I had tried this before, and maybe this is because of that that exit interface that I did put. Anyway, I think it's good that we see this so that we learn. Packet tracer doesn't allow us to do. Anyway, first of all, I think I need to first remove it. Do no. So we do IP routes. We're supposed to first do the next top IP address, which is the packet tracer doesn't allow us. This is how you're supposed to do it. You put an IP address and also you put an exit interface. So anyway, let's see whether that's what is affecting our pings here. Yeah, that's, you see what they were saying here, that it can feed it can impede performance. For a LAN interface, let me clarify this. I think I've confused you enough. On a LAN interface, yeah, so when you're talking about gig and fast Ethernet and all that, don't use the exit interface, use the next top IP address. Now, and I think now to explain that thing I was talking about, recursive lookup, if we type show IP route and come to where we have this static default route. So when this router gets a packet, just like the way I'm pinging, you see, for this router to route this packet to this guy, it will see that I don't have, it will consult the routing table, then it will see that I don't have anything 8.8 or 8.8.8. So I'll have to send it to the gateway of the last resort, which is this here, because that IP address will match. If it doesn't match anything here, it will definitely have to match this, because this one says anything else. Yeah, so it will see that I need to send it here. Then my router will ask itself, how do I get here? How do I get to this IP? Then it will come back to the routing table again and see I'm actually connected to that network. So you see, for it to send here, so it will check the routing table twice. That's what we say recursive lookup. It's no big deal when you have such a small routing table, but in a real network, and especially say the ISPs, you know, big networks, yeah, you don't want it to do recursive lookups for a lot of packets, because that's how you get a bit of slowness. So I think I've now clarified on that recursive lookup. Now I've said it didn't work on this. Now if we were to configure on router 2, let's configure a default route on this router, though I wanted to show you a shortcut, or we can actually just use the routing protocol to take that default route and advertise it to the rest of the network. And that point makes sense when you have a big network. Yeah, you can imagine if it is like on this network, then you go to every router doing IP route, then you point it to the right to the right router, it will cause issues. Anyway, what I mean by that, let's configure on this. Now imagine that you have to go on every router in your network and do the same default route. So we can do IP routes all zeros, which means is any network that have any subnet mask, just send it to we are on router 2, so the guy that is in best position to get you there, yeah, to get you to the internet, is this one here. So .65 will be the gateway of the last resort. But I'm saying, because this is a serial interface, and the router knows on the serial interfaces we don't do ARP. Yeah? If you have to do packet sniffing on this, I think I've belabored on that enough. So anyway, we can just do which interface is this? Serial. Let me hover my mouse. Serial 000. So we can do S0. Hey, typed 9. S000. It's still giving us the same warning, but I think now this will be able to. Damn, we'll not be able to test it because our ISP does not know about these networks. So in the real sense, we are supposed to configure NAT on this router, but I think let me not jump ahead and configure NAT on this, because we can actually configure NAT and you'll see it working. So what I'll do is configure a default route on the ISP pointing to our network, yeah. But normally that's not, as in an ISP will not have a default route pointing to you. If you do that, you'll have created a black hole in your network, yeah. They don't do that, but just so that we can demonstrate, we do IP route all zeros, then we do I think I still have my network in the buffer, and that's .2. We hit enter. So I was going through all that trouble to demonstrate that when I do IP route with an exit interface that is a serial, interface and I try to ping 8.8.8.8, you see that one is working, yeah? Whereas when we did an IP route with this as the exit interface, it had issues. Because a LAN interface, you're not supposed to use an exit interface. But using an exit interface, I've said it improves on things because our router now will not do recursive lookup. So when you type show IP route, just so that you can compare with the other one, you can see that the router knows about that default route and it knows that I need to send it directly to that interface. Unlike what we have with router 1, you can see that the default route, the router knows about it. And the first number we said is administrative distance. The second is the metric or the cost. So the administrative distance of a static route is 1, meaning that if my router learns about this network using RIP, it will believe me more, yeah, the administrator. It will believe the network administrator more compared to the routing protocol. But anyway, I think we'll see those numbers more as we look at the routing protocols and appreciate what I'm talking about. But anyway, I was bringing you back to router 1 to see the difference. Yeah? The point of this video, and I think it's now getting way too long, was to demonstrate that instead of going to every router, and I have now removed that default route, so I now can no longer ping 8.8.8.8 because our router doesn't have that thing in the routing table and it doesn't have a default route. Yeah, and you can see that it's failing. So we can use the routing protocol and it will help us populate that default route. That way we don't have to go to all our routers. Well, in our case, it's a small network. This is no big deal, but anyway, we are doing this to get that concept. So we do router rip, then you do default information originate. So you go to your stub router. The edge router is the only one that you configure a static default route. You see, it's an S. We know that it's a default route when it have that star, yeah, that star, because if you come to the whatever here up here, you can see that the route that have that is the candidate default, and the moment you do that, the gateway of the last result is set. So in fact, before I hit enter on that command, let's come back to router 2 and type show IP route. You can see that it have no route that have an asterisk, that star, and the gateway of the last result is not set. So let me hit enter on my router 1. Back to my router 1, enter default information originate, come to router 2, hit the up arrow to look at the routing table. Now you can see that we have a default route. Now it's not static, it was learned via the routing protocol, and the gateway of the last result is adjusted as per the router that we are in, yeah, because for router 2, for it to get to the internet, it needs to go to .65, the next hop IP. So if we come to router 3, we expect it to have a default route pointing it to .69. So if we type show IP route, you can see that it has a static default route and is pointed to the right IP address. Yeah. Looking at the time, I think we'll stop there. so that we have part 2 of this video, so that we don't have a too long video. So with that, I hope this has been informative to you, and I'd like to thank you for watching.